corresponding to 0 initial velocity and initial deflection f of x equal to k into sine of x minus sine 2x given c square equal to 1. So here again it is the problem based on vibration of string. So we will have the problem is based on vibration of string. So the equation is given as uxx equal to 1 upon c square u pt. This is equation number 1, and c square equal to 1. So you can put this value. And the conditions. First of all, you write down u0 comma t, ul comma t. The length of the string is given as L. So both are for 0 less than or equal to x t greater than or equal to 0. And you can see that string of length x and x fixed. Ends are fixed, so these two values are 0. And then the third condition is ux comma 0. And the fourth condition is ut x comma 0, velocity value. And the velocity is 0 velocity, 0 initial velocity. So it is now 0. And ux comma 0, that means this value is given here. K into sine x minus sine 2x. Then we can start directly that we know that the solution of the above IBPVB is given by ux comma t equal to sigma n equal to 1 to infinity sine n pi x upon L into an cos n pi ct upon L plus bn sine n pi ct upon L. But here you can see that as the value of gx is 0, we have bn equal to 0. Bn equal to 0. I told you already that either fx equal to 0 or gx equal to 0 will be given. Gx is 0, then bn is 0. Fx is 0, then an will be 0. But fx is given here. Therefore, our solution will become now ux comma t equals sigma n equal to 1 to infinity sine n pi x upon L into an cos n pi ct upon L into an. An just I will write down here because this is 0. Now we want to use the fourth condition, this condition ux comma 0, and that is the value of fx. And we know the value of formula for an as we used in the last one, 0 to L fx into sine n pi x upon L dx. But see here, the condition is given into sine form. Conditions is given into sine form, and the right hand side is also into sine cos form. So no need to use this kind of integration. We can find out the values of the constants. Here the constants an means what we are obtaining, a1, a2, a3, a4, we are obtaining this kind of constants because sigma is there. So using the fourth condition, so you should write down here that using ux comma 0 equal to this one. So we have this value is k into sine x minus sine 2x equal to, if we put t equal to 0 here, t equal to 0 is there. So sigma n equal to 1 to infinity an sine n pi x upon L and cos 0 is 1. So if we expand the sigma for n equal to 1, we will have a1 sine pi x upon L. Okay? Are you getting? Okay. If we put n equal to 2, we will have a2 sine 2 pi x upon L plus a3 sine 3 pi x upon L and so on. Now, here in the problem actually of length, not x, sorry, it was the length pi. So L equal to pi, L equal to pi. So if we put L equal to pi here, it will become sine x only. If this pi and L will be cancelled, so 2x only. This pi and L will be cancelled, so it is 3x only, and plus dot dot dot. So this is the sigma. Now we can obtain the values directly. See here, we will compare on both sides the coefficients. The coefficient of nx only, sin nx only, because pi equal to x. So here sin x has the coefficient here a1. Therefore a1 equal to, and here sin x has the coefficient k, a1 equal to k. Sin 2x has the coefficient a2, and here sin 2x has the coefficient minus k. Then sin 3x has the coefficient a3, and it is not there, so that is 0. Similarly, a4 is not there, a5 is not there, so all other constants are 0. So only two constants are there. So we put their values in this solution directly. Sigma n equal to 1 to 1, n equal to 1 when sigma n equal to 1 to infinity. Here I am not repeating again. Dn was 0, so we can write this one. So n equal to 1, that means a1 into sine this nx means x into cos ct, plus a2 sine 2x into cos 2ct, and all other constants are 0, so we will keep as it is. And then we will put a1 equal to k and a2 equal to minus k. So this is our final solution, you can see. So here we have not used the integration. You can solve the same one by using integration, but it will take some time for integration. But if you observe, if you observe that the conditions are given in terms of sine and cos, then you can do it very easily. Okay. So see here, and one request to you, that you must solve these examples. You must get practice at your home by sparing some time today only. And if you will solve these examples today only, and if you will write down the theory, then surely you will get 7 marks from these problems in the examination. Okay. One more example, just I am giving to you as an exercise, and for your assignment also. One example: a tightly stressed string with fixed endpoints x equal to 0 and x equal to L is initially in a position given by ux comma 0 equal to u0 sine cube pi x upon L. It is released from rest from this position find the displacement ux comma t at any time and at any distance from the end x equal to 0. So see here, actually this is for your homework, this is for your assignment, but just I am giving you the hint. This is the problem on vibration of string. Okay, and the conditions 0t u L comma t, the length of the string is given L, so we will keep it as L, and both are at fixed, both ends are fixed given, so these are 0. Then the condition for at time t equal to 0, it is also given that initially it is set in a position ux comma 0 equal to u0 sine cube pi x upon L, and last condition, this is based on velocity. Here again initially in a position, this was in position, and then it is released. So velocity is before releasing it. So here we are considering velocity equal to 0. So simply we require to find out in the last example. Yeah, you can remember this very easily. Okay, and you can here use the formula of sin 3 theta equal to 3 sin theta minus 4 sin cube theta. 3 sin theta minus 4 sin cube theta. That means sin cube theta equal to 1 by 4 3 sin theta minus sin 3 theta. And as this condition is given in terms of sine, as in the last example, you don't require to integrate to find out a0, a1, a2, a3. So that means an, you can find out the coefficients a0, a1, a2, a3 and so on by comparing on both sides. So here the solution answer I am giving to you, ux comma t equal to 3u0 by 4 sin pi x upon L into cos pi ct upon L minus u0 by 4 sin 3 pi x upon L into cos 3 pi ct upon L. So this is the answer for this example. That means here you will be able to determine the values of A1 and A3. A1 and A3. Then A2, A4, A5, A6, all the constants will be 0. Okay? Have you understood this one? So this kind of examples can be asked in the examination. One more example for your assignment I am giving here. Example number 2. Find the solution of the wave equation utt. Here equation is already given. Utt equal to c square uxx comma 0 less than or equal to x less than or equal to capital L. Here instead of small l, capital L is used, satisfying the conditions u 0 comma t equal to u capital L comma t equal to 0 for t greater than 0, greater than or equal to 0, or greater than 0 will also be allowed. U t x comma 0, here both conditions is written first, that means velocity is 0, and u x comma 0 equal to pi x upon L. This both are for 0 less than or equal to x less than or equal to capital L. So here you must have to write down first in solution the given equation, then these four conditions, and then write down below that the solution is given by this one, and here velocity is 0, so Bn will be 0, so you will require to find out only An, and here the condition is given into the form of pi x upon L. So you need to use this integration formula 0 to L fx sin and pi x upon capital L dx. Fx will be pi x upon L. Pi upon L will come outside, so only here it will remain x only. So x into sin. So you can consider u into v. So within one step you can integrate this one. So integration will be very easy here, and then put the value in the solution which we have written as we know that. So the answer for this is given by answer. You must note down ux comma t equal to sigma n equal to 1 to infinity minus 2 minus 1 raised to n upon capital L into sin and pi x upon capital L into cos and pi ct upon capital L. This is the answer. So these two examples are for your homework, and you must remember here that every year one question, one example always comes in examination based on wave equation or heat equation. or Laplace equation, but one equation must be from wave or heat, and you can solve this. Once if you have known this, the heat equation is very simple. Nothing is more than this solution process. Instead, some less number of steps we will require to solve heat equation. So you must get practice this, because you must have observed that here no more complicated formulas have been used. Only simplification and simplification of the steps are required, and these are very easy as you are doing in the school. Okay, so nothing more than school level here. The process is lengthy, but steps are very simple to simplify, and you can see all each and every examples very easily. Okay, thank you. In the next lecture we will see heat equation.